the speaker. Okay, Dr. Moez, he's from Tunisia, and he says he's in the southern part of Tunisia now, okay? But it's a beautiful country, Tunisia, you see, and you will enjoy if you have the chance to go. It's a lot of history, people are really friendly, you see. They are like the Spanish people, very friendly, very friendly. Wow. So that's great. Okay, he's going to talk us about the history of artificial intelligence. You see, he's a Fulbright visiting scholar, and he actually visited Puerto Rico a few years ago. You see, as also when he was having a research internship for a year in Berkeley, University of California, Berkeley. Okay, Parag, I'm sorry, Moez. I just confused with Parag. Parag is our assistant. Okay, all right. So
Yes, sir.
welcome to this audience. This audience is mostly from Bolivia in
Oh,
Cochabamba. Okay, so these are students who are working in the project. In the project that we have, a Saru Research Academy. It's virtual, and so we put some conference with people from around the world. We used to have somebody a few weeks ago from Moscow State University. So I have my friend there. So they were talking about uh, astronomy, and now we are going to see the history of artificial intelligence. Okay, Moez, the floor is yours for your
thank you,
comment.
Juan. Thank you for this invitation. So,
Yeah.
hola, everyone. So, and especially people from Bolivia. And I hope you are enjoying, and you will also enjoy, the Saturday seminars with Professor Juan. So, okay. So in this talk, I will just point some subjects like why did artificial intelligence come from, what is AI, and what we should worry about because there is some worries. So I think perhaps most of you watched this movie, the iRobot with Will Smith. It's really a great movie. And it's science fiction. It's talk about Chicago in 2035, where highly intelligent robots, fill the public services positions, and let's say they are replacing a human, and a robot is suspected of killing a human. Okay? But robots are ruled by the three laws of robotics, and they should not harm people. So, Will Smith was trying to catch the murderer and understand what's going on. So you know that most of the movies are inspired by a book or a writer. So who knows about the inspiring writer of this movie? Any guess?
No.
Okay, so the writer is Isaac Asimov. Oh, this guy is researches in chemistry, but he's very famous for his writing. So he wrote a robot series on from 1940 to 1995, and you see here, so the iRobot was coming from this book. So most of today's AI researchers, they read this robot series. So Isaac Asimov inspired or influenced, our today's AI, stuff. So let's talk about, about the AI history. So, what about AI? And so AI started with robotics. And when we talk about robots, robots are machines capable of carrying out some complex series of actions automatically. And the purpose is serving humans. And there's a book called Book in Knowledge of Engineering Tricks. So it describes 50 mechanical devices, powered by water, no electricity. And this book was published in 26. So let's say 8 centuries ago. So who's the author of this book? So you see, it's very old stuff about mechanics and robotics. So this guy is Al-Jazari. So this is an Arab engineer. And what he did is building, some, let's say, toys, okay? Or here we have mechanical dolls. And here it's showing, a picture. So Al-Jazari is showing a picture of describing, his, let's say, robotic stuff. So this is a boat with, like dolls playing instruments, and you see how the water is going on, and it was like an advertisement for the king in the king's palace. So you put this boat in a pool, and each 30 minutes, automatically this boat starts, or this doll start playing music, and each robot is like playing some kind of sound. So this was 8 centuries ago. So just to show you that, let's say, or robotics is very old engineering or human dream. So let's define what is AI. So AI is making, intelligent machines. So what does it mean? So machines are intelligent, to the extent of that their actions can be expected to achieve their objective. So we define an objective, and the machine or the AI should do it. So it can be a robot or it could be a piece of software, but we have to specify the objectives, and this AI should achieve or make actions to achieve the objectives. So we can here we have two parts. We have the thinking and acting. So let's talk about thinking. So humanly, what is thinking? Thinking is, the automation of decision making, problem solving, learning. But rationally, thinking means that we make it possible to perceive, reason, act. Okay, so this is the rationality behind, thinking. But when we talk about acting, so humanly, acting means that you do things at which people are better. So let's say I can teach people, I can, let's say, cook for people, and so on. Now, rationally, acting means we operate autonomously. Okay, we perceive the environment, we adapt to change, and we can create and pursue goals. So to create, let's say, AI or intelligent machines, what we do, we go from what is humanly, done to what is rationally done. So we have to define, let's say, these actions and this intelligence regarding the rationality. So our brain is very good at making rational decisions, but it's not perfect. So there is, let's say, two ways of thinking. There is a book called, Think Slow and Fast. If you think slow, it means that you make, let's say, the calculations and the reasoning in your brain, then take the decision. If you think fast, it means like you are guessing some stuff. Okay, you go fast, you don't have an explanation, but perhaps you do it sometimes right, sometimes wrong. But so our brain is very good, but it's not perfect. So human always do or have some errors, or some percentage of errors. So scientists, and let's say, they studied the brain, human brain, mouse brains, and all that stuff, but it's hard to understand how our brains work. And let's say we are not really able to explain it, and AI may be better than brains at some tasks. Okay, if I want to predict the weather, I can predict it, but AI can do it better than me. let's say if I see crops and I have to, let's say, detect diseases, I can do it, but AI is more precise. Okay. And if we compare, our brain. So we have neurons, and a connection between two neurons is called synapse. So our brain, depends on the intelligence of a human. So the number of synapses is around 1 trillion synapses in our brain, okay, on a human brain. But if you compare to the weights of GPT-5, it's around 2 trillion. So we have 50 times more synapses than the actual most powerful today's AI. So AI is able to do a lot of stuff, but our brain is bigger and we are smarter than the AI. But it's not perfect. And in some tasks, AI can be better. That's the point. That's the comparison between what is human and what is AI. So this is the humanly comparison. But if you go to rational, so what is rational? It's, let's say, maximally, achieving predefined goals. So let's say my goal is to, let's say, sell 100 items per week. Okay. So rationality says that, I have to maximize, this goal. So if I sell 90 of 100, yeah, it's good. Because rationally, you know that uh, the probability to sell 100%, it's really hard. So that's why we say be rational. You had 90% of your goals, you should be happy. So what are goals? We have to explain or to express our goals. So our goals are, expressed in terms of utility of outcomes. Okay. So being rational means maximizing your expected utility. Okay. So your expected utility is, the items you have to sell, the ill people you want to cure. So this is what we have to express. Now, let's say today's AI started in 1943. So it started with some Boolean circuits. Okay, so Boolean circuit means you have some electronic component that is Boolean. It means the value is 0 or 1. But we started, mimicking or trying to do the same thing our brain is doing, but just some circuits expressing 0 or 1. So by the end, a model of artificial neurons. So we have, let's say, natural neurons on our brains, but we want to create artificial neurons. So in each neuron was characterized by being on or off. Okay, so it's like ignoring or activating, such action or value. In 1915, Turing started the computing machinery and intelligence, and the famous Turing test. So what is the Turing test? So the Turing test was, you have a human, okay, you have a machine, and the machine should imitate the human. And if you have a human's, let's say, interrogator, or a judge, so the C, so C has to ask A and B questions, but C doesn't know if A is a machine or a human, and doesn't know if B also is a machine or human. So C starts asking questions for both and trying to distinguish between, or to guess if A is a machine or a human, and also B. And most of at the time, AI were not able to pass the Turing machine, okay, or the Turing test. But today, you can ask, if you are chatting with let's say, ChatGPT, if you write prompts, the responses are like human. You can also talk through voice to ChatGPT, and you will have voice responses. and it's hard to distinguish between a machine and human. So most of today's AI are passing the Turing test. So we are at a new level or a new era of AI. So the Turing test is, let's say, defined by let's say some points. So a machine, needs to possess these capabilities. First of all, it's natural language processing. So the communication should be successfully in English. So you write some English text, you get some English text. Okay. So now, you can use even other languages like Spanish, Arabic, French, and other. And so the knowledge representation, so the machine can store, means memorize. It can also it can hear, have some knowledge, and also it can hear you. So now we are communicating using speech voice. So AI is passing this test. Automatic reasoning. So I'm sure you previously interacted with ChatGPT and like Gemini and others, and there is a lot of reasoning inside it. Machine learning, when we talk about machine learning, it means that the machine is able to adapt to new circumstances and detect, or extrapolate patterns. Before, if you have a formula of an algorithm, it's hard to adapt to new circumstances. So machine learning can do it. And today, I know ChatGPT is able to rely, or to extrapolate patterns and stuff like that. We have also the computer vision. So now, if you feed ChatGPT with the picture, it's able to understand and describe it. And the last point is robotics. So AI should be able to move, etc., and even move objects. And we see that we have these robotic hands and these smart robots today jumping and playing basketball and soccer. So uh, let's say we spent 60 or 70 years to pass the Turing test. So Turing was a very smart guy. In 1995, Samuels created a search tree. Okay, so you see here you have when you have to search. So it created this.
Wow.
You see the board, and you have different, let's say, possibilities. And so you describe the different possibilities, and you have this backup. So if you do this, you move, to this like case. What is the backup? What is the, let's say, the outcome? If you will win or lose, and you see that this all this stuff is one machine. So it was very old and large machines. So in the 50s, when the Russians, started, they went to the moon, and so in the US, they needed to translate the Russian, text or Russian papers to understand, the Russian research and compete, for the, let's say, the moon exploration and the going to the outside of the Earth. And at the time, it's very expensive. It was very expensive to find. It wasn't easy to find people, understanding Russian and translating the text. So one solution was to just translate, the code. So in the Russians, they launched Sputnik in 1957, and at the time, U.S. researchers, they created a dictionary. Okay? So the idea was to replace, when you have a sentence, you replace each English Russian word by an English word. Okay? But it was word by word. So when they did the test, so translating, the spirit is willing, but the flesh is weak. No, it's some text from the Bible. So let's say, imagine that this stuff is written in Russian. So when you translate it to English, it becomes the vodka is good, but the meat is rotten. So because let's say you translate the spirit from Russian to English, it becomes vodka, and the flesh becomes meat, and wheat becomes rotten. So it didn't work. So this translation word by word doesn't work. And let's say today's translation, if you go to Google Translate and translate from Spanish to English, let's say no hay color, so it means there is no color. Juan, is it correct?
Yes.
Yes. Okay. So let's say English, when you translate English is, let's say from Spanish to English, it works well. In some other languages, it's not that good. So then, we had the Dartmouth meeting. So because this date was the first, adoption of the term artificial intelligence, and people started working on it. So we had what we call the logical reasoning. So it was, you see here, it's just math representation of some logical reasoning. It was good for some stuff, but it's not very expressive. And in the 70s, 80s, people started creating, the expert system. Let's say instead of going to the doctor, you need to try to, let's say, digitize the knowledge of an expert. You have a doctor, and you want to digitize his knowledge. So we create what we call a knowledge base. It's not a database; it's more advanced way of storing data. It's storing knowledge, and we had an inference engine based on this math like stuff. And we have a user who was like today, writing some prompts as query and getting advices. Today, you do it with ChatGPT, it can work. Okay? Be careful, but because sometimes it's, especially for, you have to ask a doctor, never do it. But today we can have good, let's say, advices from ChatGPT. But in the 70s to the 90s, it wasn't good enough. Then, we added the probability and decision theory to AI. So we start using, what we call the tree search, and we had also the minimax algorithm. So it was built by IBM to play chess. So the idea is, for each possible move, you have to calculate all the possible moves of your opponent, and you have to score. Yeah. So for you, the best score, it should be, it's 9. Okay. So we have to choose one of those. But at the time, the machines were not very powerful. We didn't, so the RAM, so the memory was very expensive, even the disk. So we don't have enough space to for all these simulations or all these search trees. And IBM, I know, they developed what they called Deep Blue in 1997, and Deep Blue, defeated Kasparov. So Garry Kasparov was, I think it's even today, the greatest chess player. And Deep Blue was able to defeat Kasparov, not at the first time, but at the second time. Okay. But there is also always, some people say that he got some money to lose. I don't know. But it was like a big stuff. In 1997, Deep Blue defeating Kasparov. Then in 2002, we started having the embodied AI. What does it mean? So we had this Roomba vacuum, and now you have a vacuum which is able to clean your house automatically. But you see that this design was in 2002, but this one is 2024, and we have a better design and even more advanced features. And today you can have, let's say, a smart vacuum, but in 2002, it was a little bit done. And uh, um, this advance of AI, was also boosted by something. It's called big data. So between 2010 and 2017, we had this boom of big data. And Obama was the president who, let's say, financed the big data research and implementation, and it was very successful. So why we talk about big data? Because companies like Google, Apple, and Yahoo, so they have a lot of services, search index, search engines. We are using the emails. So they collected a lot of data because the disk or the storage became very cheap. So when we talk about big data, it means that we have big volume, very large volume. So we have terabytes of data. We talk about also the velocity. So data are very fast. Like people now are posting and reacting on Twitter or X. We have a variety because data now it's text, it's SMS, it's voice, it's image, it's video. So we have different shapes. And we have the veracity because we don't trust everything on the web today, especially social media, because there is a lot of fake stuff, and we should not, let's say, we should also be critical to what we see on the web. So this is the data. So big data gave a lot of data to researchers and to AI. The development of GPUs. So GPU means graphical processing unit. So it was boosted by NVIDIA, for, let's say, game playing because, the very advanced graphics, but it's very important because it boosted, what we call vector calculation, because the graphics processing unit, when you have to display something, it's a matrix. So the matrix is composed of vectors, and GPUs are very fast, at processing vectors. So we started using GPUs for AI, for biology stuff, yeah, and then when you talk about deep learning, it means we have artificial neural networks, and deep learning needs a lot of GPUs. So when you do deep learning, you need at least one GPU, but which should be powerful enough to run and train your model. So when you talk about deep learning, we have artificial networks, and we have automatic feature extraction. So like when you want to distinguish between cat and dogs, what are the features that help you to distinguish? And deep learning needs two things: large volume of data. So it was fueled by the big data revolution, and computation power, which is fueled by GPUs. So big data and GPUs helped researchers to do let's say, AI with artificial neural networks, which are deep. So before deep learning, we had what we call machine learning. So in machine learning, let's say you have pictures, and all you need to say is if this picture is a car or not a car. Okay? It's just binary classification. So we have an input, it's a picture. You need a machine learning engineer who will work on feature extractions with a lot of mathematical math tools to say, okay, we will use this and this features to extract if it's a car or not. Then you need, let's say, an artificial neural network to do the classification. So when this neural network is shallow, it means that we are doing just machine learning. Now, what does it mean going from this neural network to this one? So from machine learning to deep learning. In deep learning, we don't need a human to do the feature extraction. So we will have what we call layers. We have a layer to extract features, and we have a layer to do classification. So feature extraction and classification are in an artificial network, which is deep because we have a lot of layers. And this deep learning is very fast compared to using a human to do the feature extraction. And we can have really better models that are able to learn from a lot of pictures, so from the big volume. So let's say we have today a large volume of pictures of cars and other, let's say, motorcycles, buses, trucks. We have the GPU to train the neural network, and so we have today better, let's say, AI models. Then we had a lot of new stuff. We had, Apple in 2011 released Siri. Okay, so Siri, let's say, it's a vocal chatbot, so you can talk with Siri. In 2012, AlexNet. So AlexNet was using deep neural network. So it wins the ImageNet competition. So it's a competition to classify images. And AlexNet used, the convolutional network, the CNNs. And here we have the birth of the deep neural network. So in 2012, we started with the deep neural networks. In 2015, DeepMind achieved a human level control in Atari games. So let's say this one is using what we call reinforcement learning to learn how to play. And let's say the AI was able to do like and even better than humans. In 2016, so everybody knows about Google Translate. So Google Translate historically used statistical learning to translate because it was the statistics were better than machine learning for translation. But in 2016, they migrated to deep neural networks. It means deep neural networks are the most efficient, let's say, tools to do AI. And most of the big companies, migrated to deep neural networks. It was in 2016. So by the end of, let's say, 2016, we had, let's say, what it's called, AlphaGo. So AlphaGo, it's the DeepMind, let's say, AI that defeated, Lee Sedol, who is, the best player of Go. Okay, the world champion of Go was defeated by the AlphaGo. So it was a new achievement in 2016. But in 2023, some amateur, exploited a weakness in this AlphaGo system and were able to defeat, this AI. So human amateurs are not able to defeat Lee Sedol, but they defeated the machine or the AI which defeated Lee Sedol. So because AlphaGo was trained to defeat, master players, not amateurs. So the amateurs found some tricks and were able to defeat the Go, AlphaGo. Till 2017, till now, from 2017 to now, we are talking about large language models. So ChatGPT is a large language model. Gemini is using the large language model, Claude. So all the models you are using today, or the generative AI, it's based on large language models. And it started in, let's say, 9 or 10 years ago. So what is a large language model or a language model? So a language model predicts what words come next. So everybody is using to that. When you text someone, you are using, your smartphone keyboard. So if you type Puerto, okay, so you see some, let's say, suggestions. So it can be Rico San, Rico Miami, etc. So your keyboard is using a language model, What does it mean? When you write a word or sequence of words, it will predict the next word. That's it. Okay. But this one is very small statistical model. Now ChatGPT is predicting the next word. Okay. You give it a sequence of 100 words. So ChatGPT will predict, the next one. So this is the main idea of a language model. Why they are large? Because the size is very, very large. So from where come these language models or LLMs? So in 2017, Google invented the transformer architecture. Then AlphaFold, predicts the protein structure from amino acids based on these transformers. Modern text to image generation. So now you can prompt and create an image. It's also based on these transformer architectures. In 2022, OpenAI released ChatGPT, and it's based on this transformer architecture. Today we have Claude, Kimi, Qwen, and a lot of models which are even open source. And all these models are based on this transformer architecture. So we had a first, let's say, boom of these deep neural networks. But in 2017, after the Google, invented the transformer architecture, everybody's using it and till today, and these are the best, let's say, models. So now I'll give you, let's say, a brief history of AI, from where we started and where we are today. But should we worry about something? AI is powerful, but how it can go bad. So I'm sure you watched the Avengers movie, and Thanos, collected the Infinity Stones. Why? Because Thanos, defined an objective. What was it? Let's say the universe was living in a severe cut of food, and they had a lot of pollution. It's like what we are seeing today. So he had the thought: if there were half as many people in the universe, okay, so reduce the universe people by 50%, the remaining people will be more than twice as happy. So it's an objective. Kill half of the, let's say, universe, and the other half will be happy. It's an objective, okay? But it's not ethical. You cannot do that. You are not nobody has the right to do it. Okay, so we have the right to live, and even if life is not that good, it's our right to live. Another objective can be, kill as many as possible. So in war, in the war of Gaza, Israelis were using AI to maximize, kills when they are throwing bombs. So this is not ethical, and we should not use AI to harm people. We should use AI to help people. So if I recap, as takeaways, so Turing designed a test that remains relevant 60 years later. Now, 6 disciplines, so what was defined by Turing is what defines our 6 disciplines that compose most of the AI of today. Okay, so Turing was, I will say that he was smart enough to design what we are doing today. So technologies like GPU, software, networks, so data, etc., they boosted the AI. Okay. And also there is a democratization of AI through open source, because when we talk about open source, there is platforms like GitHub where you can find open source code. It means you find code in Java, in Python, so for a game, for an application. And then we had a Hugging Face So Hugging Face is a platform to share AI models. So on GitHub, we have open source code for programming, and in Hugging Face, we have the open source models like for Llama, Kimi, and others. We have open source models like Llama, so from Meta. We have also models from Databricks, but we have also a lot of Chinese models today. And there is a lot of free courses online. Okay. And this helps people today, to find the models. There is open source model on these platforms. We can find free courses like Kaggle and MIT, Stanford, Berkeley. We have a lot of free courses. So everybody today is able to learn AI. So the future of AI is not AI versus human, okay? Because AI will not replace human, and human also will not replace AI, but we can co-evolve and we can work hand in hand with AI. So we should look at or see it as AI and human team. So we work together. So we can have, let's say, AI for human, not AI versus human. So it depends on how we will use AI and how we should implement. So thank you for your attentions, and don't hesitate to ask me any question you want. Thank you.
Well, thank you very much, Moez. It's a very interesting briefing of what the history of artificial intelligence is all about. Yes. Personally, when I was doing my PhD, you see, I had the fortune to work with people from McDonnell Douglas, okay? And they were looking for a way to design, you see, how we can control an airplane, you see. And of course, I learned about expert system with them. So I did something in my dissertation about expert system, dynamic for a robot, okay? So those were 85. It was the initial table of artificial intelligence, the basis. But some companies, they were pretty advanced. You see, right now you have almost all the plane, when they are landing, when they are flying, it's an automatic machine that is doing it. Probably the pilot is just controlling that everything goes well, right? But the advances are absolutely important. Industry, automation, and all those kind of stuff, you see, are really very important product of this technology. Okay, thank you for your time, Moez. And I'm not sure if there is any question aside from me, okay, from my remark. Jiria, you had any question?
I have a question for Moez. About artificial intelligence is based on what is fed from humans, right?
Right.
So how do you visualize like the feeding of information that is not like incorrect information into the artificial intelligence? How does that affect the outcome?
Okay. Thank you. It's a smart question. So let's say the neural network here is not smart. Okay? It's learning from what we are feeding to it. So if I provide a picture of a track and I say it's a car, so for this AI it will be a car. Okay. So if it's wrong, it will learn wrong stuff. So the first rule of AI, they say garbage in, garbage out. So if you provide with garbage, the model will be garbage. But let's say first step, if you want to do AI, you have to create data, this input. So you have to collect a lot of data. Now, your AI, the quality of your AI depends on the quality of your data, part of it. So you have to curate your data. And secondly, we can have bias in the data. Some researchers did, like they generated a lot of, they asked AI to generate fiction, okay, story, and they discovered that 60% or 2/3 of the fictions, the heroes were men. So we have the bias based on the gender. There is also a researcher who developed an AI that learns to depixelize a picture. It means what? You provide, an old picture, the resolution is not good, so it's pixelized. You provide it to the AI, and the AI will regenerate, the picture. Good. So one guy tested this technique with the picture of Obama. So it provides the model with a pixelized image of Obama. And when the AI regenerated the picture of Obama, Obama was had a lighter skin and blue eyes. Because the training data was used only on white people.
White people.
So it doesn't work for like black people, doesn't work for Indian people. So let's say if you are brown, even brown doesn't work for you. So now we have a lot of models that are able to, I don't know, provide, let's say, medication and stuff like that. So if you test it with people living in Canada, I think it will not work for people living in Bolivia or in Africa because we don't have the same genes. Okay, so today everybody knows about let's say the quality of data, which it should not be wrong, but we have to be careful. It should not be biased. If it contains bias, it works for some people, but doesn't work for the other. Did I respond to your question?
Yes, but also I was thinking on how can you control the input, because the input comes from anyone. How does
Okay.
AI manages all the garbage input? So
Okay, I see.
garbage output.
Okay, so the input, let's say if it's pictures, it should be annotated by humans. So we need human to say this is a car, this is a bike, this is a truck, etc. And so one of the techniques is you can use the crowd. Okay, when you use the crowd, so let's say you don't have 5 annotators, you have 100. If 80% are serious, okay, you will have 20% of contaminated data. It doesn't matter. It's okay. It's not a big deal. But if 80% of your data is wrong, it's a problem. Okay, because it's always a probability. So you mean it means that at least 80% of your data should be clean.
And are scientists designing mechanisms of cleaning data?
Yeah, but when you say cleaning data for us, that means
Like input.
If in my data I'm measuring the temperature, it can in Celsius it can not be 100 of the weather's temperature. It can be not 100. But if you have a picture, let's say I cannot control it. I need to let's say at least create a small model that classifies. And if I have a small probability, I need human to control. So everything should be under the control of a human being, not 100% automated.
Okay, thank you.
Perfect. Yes, we have one person coming out of South Africa. Lukman. Lukman, do you have any question, any comment? Lukman. Lukman was one of my students during May and my visit to Cape Town.
Hi, sir. I just wanted to ask if the slides will be made available, because there were some interesting topics within the slides that I'd like to do further research on personally.
Yes.
Yeah,
Yes,
sure.
look, man, the slide will be, or assistant will provide that, and I will send you the link just to see the complete presentation.
Okay.
Because
Thank you.
that's something important. Yeah, if you want to go.
Okay.
Yes.
And you have the recording also.
Yes.
Yes.
The recording. Yeah, the recording will be available. Okay. And also, what we had to do, normally we do, if you open your camera, we take a picture of all the people who came to this meeting. Okay. So to have your picture.
Should I stop
and
the
your
presentation
face.
or I keep it? What do you think?
Oh well, that just
As you
leave it.
like.
Yeah,
Keep it.
yeah, I think yeah. That's good. What? Somebody else is everybody. Barak, can you take the picture? Barak, are you there, Barak, or not?
Yeah, Dr. Rohan, I think we need to stop sharing the screen so that we can capture everyone.
Okay, yeah. So all right, that's it. That's also. Thank you much. Thank you much, Barak. Yeah. Something else. We had an evaluation for Dr. Moez presentation, so it's available in the chat, right, Barak?
Yes.
Yep, it's available in the chat.
In the chat. Yeah, so that's the link, and you can do that. I think I really appreciate, Moez, you are coming to this meeting from Tunisia. You see, we have people from Africa also, one student, and we have the other student, Mylene. Mylene, are you there?
Yes, doctor.
Yeah. Can you show us something of your presentation? Because so Moez and the rest can see what we do with the student. It will be just the 5 minutes, right? Do you have
Okay.
a presentation?
Yes.
Perfect. Yes. Yeah, Mylene is one of the student Moez that we are mentoring. Yes. Yeah.
Welcome.
Yes.
Can you see there?
Not yet.
Okay.
Well, this is my only presentation. Just I am prepare my
Okay.
post.
Yeah.
So
What about
the last.
okay, yeah. Now we can see it. So okay, you had the structure of your poster, right? That's what you
Yeah.
are presenting? Yeah, perfect. Yes. Yeah.
Okay, here this is the title, Advancing Diagnostic Precision Through Multi-Instance Constructive Learning. So in this week, we're working about the future work and acknowledgements. So just I am describe some a little part.
Yeah.
Well, the future work about my project will be steps focused on improving MICLE's architecture and loss functions directly, testing vision transformer and Combinex backbones in place of ResNets 152. Extended a constructive loss with a supervised constructive subcon formulation and introducing hard negative mining to sharpen decision boundaries between visually similar cases. Each change will be tested through controlled ablation studies before combining the stronger, resulting to revised MI CLE variant. Future work will also explore specialization toward clinically underrepresented dermatological domains such as STI-associated skin manifestations. My last about acknowledgements, it's the author thanks Mr. Einar Calle Viles from University of Bolivia and Dr. Juan Arratia from Scientific Caribbean Foundations for their guidance and mentorship through this research.
Cool.
All right. Thank you very much, Mylene. Yes, she will send me that, and I will give her feedback. Okay.
Nice
So
work,
we
and
can
it's a smart move to go to ResNet also.
Yeah. Yeah.
Okay.
Mylene. Yeah.
Yes?
Yeah. Can you repeat, Moez? What?
I said it's nice work, and I think it's a smart move to move to the ResNet architectures, because ResNet today one of the best on image processing.
Perfect. Yes, absolutely. Nice feedback for that. So that's what we have really. I will have more students, but I think the coordinator, we have one, Aymar is the coordinator in Cochabamba, and I will write to him about what happened with the other student, because maybe it's something special. It's the first time we don't have more students. We have just one. Okay.
Well,
all right. We had
Mr.
about yes, Mylene.
I could say like in this week we are started our classes. Maybe the other guys they have something classes for today.
Oh, maybe that's the reason. Okay.
Maybe.
That's pretty good. Thank you much for that feedback, Mylene. All right. Guys, I think we are finishing. We are almost an hour with this conference and update with the student. And I really appreciate you are coming to these meetings. We are going to have another meeting because this program is going to be finished probably by the end of the month. Okay, and we will have a symposium. We will tell you when the symposium is going to. All right. So those and the students really are just doing their project, and they are showing everything they do on Saturdays at this time. Okay. So normally when we don't have a speaker, we just work with the student pretty much in their presentation, and we start with zero, just with the title. Okay, of the research. And I didn't select the research for the student. The students select their own area of research. And that was really a learning process for everybody. Okay, so have a great day, everybody, wherever you are, Africa, Latin America, Puerto Rico. Also, that's great. Thank you very much, Moez, for coming.
Thank you.
To this
it's
conference.
always a pleasure.
Okay.
It's always a pleasure. Thank you. Thank you for the invitation.
Thank you much. Yeah. You are a real Fulbright scholar. You see, we are givers in terms of giving to other people what we know and what is positive for the world. Take care, guys. See you next time.
Bye.
Bye-bye. Yeah. That's it.